Hey, hello there, friends. I welcome you all to my YouTube channel, Club with Mohsin. First of all, may you and your family be blessed with peace, prosperity, and happiness, friends. Eid ul Fitr Mubarak. Friends, I am Mohsin Sheikh. I am two times AWS and two times Microsoft Azure certified professional with overall 15 to 16 plus years of experience in IT under various domains. Okay, so today we are going to do another hands-on using Terraform code. Okay, first of all, I will show you the code. Okay, so this is the code that I was referring to. Okay, and see, before you can continue with this session, I would really recommend you to watch my previous video on Terraform. Okay, so I am referring to this video. The title is Terraform is the best choice for cloud computing. So please watch this video. It has some basics of Terraform. I had tried to cover some basic things, the overview, how it works, all those things, because today's session is kind of bit advanced, you can say, as compared to this one. So please refresh your knowledge and go through this Terraform basics course or session. I would say this one, that even I will also share the link with the description, and then please continue with this video. Okay, back to the Terraform code. So see, as on your screen, the screen whatever you are able to see, the code is something that we are going to deploy. Okay, so what this code will do, first of all, the code will create the agenda of today. What we are going to do is we will set up a web server behind automatic scaling group ASG and application load balancer, and we are intending to get an output as the ALB DNS. Okay, out of that this code. So if you are not aware for the application load balancer or network load balancer, whatever you can say, so instead of IP we can get the DNS normally in the AWS. Okay. Another thing is, if you want to really see how load balancing works, again I will share the link in the description. Please watch for your references. Okay. Okay, so back to this video. Let me first explain what this code will do. Okay. First of all, we will go piece by piece. I will explain each of this section of this code. You can see it is around some 120 plus lines are there in this code, and then I will create the resources actually. Okay. First thing is, see, the intention of this, as I explained, this code is designed for scalable, fault-tolerant architecture with load balancing, automatic scaling, and high availability. So, as I mentioned, it will create a web server in a VPC. We will create a VPC. There are lots of resources that we are going to do. So we will set up the VPC. Inside VPC, we'll create an internet gateway, all those things. Okay, so the first section, set up a VPC. You can see we can comment out inside this one in the Terraform code via either by slash star, as you can see, or by hash. So hashing is something, you can say, a more standard way rather than slash star, that I would recommend. Okay, so the first thing is hash setup a VPC. This is the command. Okay, so what we will do is we will set up a VPC with the name demo, and we will give it a CIDR block as 192.168.0.0, and it should be under /20 subnet. Okay, /20, it is CIDR. So this VPC we would create first. This VPC, we are going to have some resources which needs internet access. So for that, obviously, as most of you know, once we create VPC, if we want it to set up an internet access, we need an internet gateway. So the second stanza here, line 8 to line 11, create an internet gateway. So this will create an internet gateway. Okay, and it will be created for VPC. We have given VPC ID as AWS underscore VPC dot demo dot id. So the way we can refer the resources is, whenever we want to refer, see, it is AWS VPC, so it will take this one, AWS VPC, and dot, what is the name is demo, and its ID. So that is the VPC ID. Similarly, we can refer the other resources inside the code. Once we create internet gateway, the next thing would be to create a route table. So we will need a separate route table, that is public route table. We will create a resource with AWS route table as the name, and again give the name as it route table as public. Referring to VPC ID, so where we need this route table would be, again it's AWS underscore VPC this resource dot demo, this one. So it is this resource AWS VPC then dot demo dot id. Okay, so this one is for route table. Once route table is created, we need to update the route table with our internet gateway, because we have just created the route table but there is no entry for internet gateway. As we do manually, here we are going to do a code. So the line 18 to 23, you can say update route table. So here we will create AWS route internet access. So the internet access would be the name of that particular route, we can say. Route table ID, again we have taken this one, AWS underscore route table dot public dot id. Okay, similar to what how we referred other resources, it is the way the resources are referenced inside this code. Destination CIDR block is 000/0. It is open to internet and for IPv4. Okay. Gateway ID is AWS internet, this one, internet dot main dot id. So by now you might have gone to understood how the resources are referred inside the code. So after updating the route table, the next thing would be create subnets. We need to create two subnets. Okay. So resource, again we'll say AWS subnet, and demo underscore subnet is the name that we have given to it. Count is, you can see as 2. VPC ID, we have referred the VPC under which the subnets needs to be created. And what would be the CIDR? So see here, the interesting thing is CIDR underscore block. So how we are going to do the CIDR for these two subnet would be 192.168, that is the CIDR, the first two numbers. Then you can see $count index dot 0/24. So here it would be, as the count is 2, the count should be 0 and 1. Okay, so the first CIDR should be 192.168.0.0/24, and second would be 192.168.1.0/24. It will be equally divided between two subnets, and this will be the CIDR. Okay, I hope it is very clear. Now availability zones, element, data, AWS availability zone, availability names, count index. See, this is something that we have not covered as part of basics, but when you come to know about the data, okay, so when resource this whenever something we will add or create with resource, so resource will actually create this resource, like AWS subnet. When we mention that resource AWS subnet, it will actually create the AWS subnet as resource. But data is something that it is a read only. Okay, so it will refer the already available values or data. Okay, it is not going to create anything. So whenever we see come to know about data, so it is some unique values which are not going to change and something like that, but these are not going to create any resources. So it is just for reference, it will refer this value, data, AWS availability zone, availability names, count index. Okay, I hope again this point is also clear. Coming back to the next point, associate the route table with subnet. Okay, since we will create the two subnets here, okay, here there will be two subnets will be created in the previous step. We need to associate the route table. Okay, so how we'll associate it? Resource AWS route table association demo subnet, and here we have given the count as parameter. So again it will be like 0 and 1. It will create associate the route table with the both the subnets, at subnet 0 and subnet 1. Here we will see AWS subnet demo subnet, it should be 0 and second will be 1. Okay, then moving to the next part, again here you can see I was referring to this section. See, data, AWS availability zones and available. So these are the values which are available already. These are not we are going to create. And here see, you can see some information is there. A data block requests that Terraform read from given data source and export the result under the given local name. The name is used to refer this resource from elsewhere in the same Terraform module but has no significance outside of the scope of the module. I hope this is clear, okay, about data that we are going to refer in the previous step. Now the another next step would be to create the security group. So since this is the associated with the web server, okay, so we need to create a security group. Here we will create a security group, AW security group, and we give the name as WebSG. Again, the VPC is we'll be using the existing VPC. Here we will give two values, ingress and egress. So ingress rule will be like incoming traffic for port 80 or HTTP, and 0000/0. So for all incoming port with respect to port 80, we will allow the traffic from internet. For egress, that is outgoing, however it will be open to all, okay, again open to internet for all ports, you can see here. Now since we need to create a launch template, okay, because we need auto scaling group. For auto scaling group purpose, we will create a launch template, and we will use this launch templates as part of our auto scaling group, inside which we will have our web servers or that EC2 instance deployed. So configure launch template. Here we will create the resource AWS launch template, and we'll give it as a name as web server. Okay, so we will give this name as web server. Image ID, see the important thing guys, see name prefix I have given as web server, but if you are doing some mistake with respect to AMI, again I am mentioning, please refer the AMI which is existing. Okay, so where you will find the AMI is, you can go to your instances, click on launch instances. For example, if I want Amazon Linux, okay, here you can see this is the AMI ID, and this AMI ID is, for each region it is variable. Right now I'm using Asia Pacific, that is Mumbai, you can see, so it is available here. But if you are using other region, then the AMI ID could be different. It's not necessary that this AMI ID is also available for other regions as well. Please validate it the AMI ID before you can proceed with the code. Okay, so this is about the AMI ID. Instance types t2.micro that I am going to choose, and here user data. So here this is a bootstrap script, you can say. So what the script will do is, it will first update all those, perform some updates using yum update -y. Then it will install httpd. Then it will start httpd daemon and enable httpd service as well. Okay, then we will put this message echo welcome to the web server into var www html index.html. So whenever we will launch the EC2 instance, it should give us this message as welcome to this web server. So this will be as part of this user data or bootstrap script, and this we are going to provide in the launch template, so that all the web servers will be having the same template, or same syntax, you can say, or same format. Now coming back to the next point is network interfaces. So we will associate a public IP address. Here the value we have given as true, and security group we refer the previously created web security group. Okay, now after launch template is ready, the next step would be creating auto scaling group. Okay, for auto scaling group, we will create this auto scaling group resource, and we will use the launch template ID which we have created in this step. Okay, so it has given, you can say, launch template.webserver.id. Version is latest. So what this means is, we are going to use the latest version of the launch template. So there could be multiple versions, but here we will prefer the latest version. Now if you are not aware about what is auto scaling group, so auto scaling group is basically, it will scale up or down the resources as per the requirement, or the way we need it to happen. Here we have given the desired capacity as 3, minimum 2, and maximum 4. What this means is, it will start with the desired capacity as 3, but it will run between 2 to 4. So there will be minimum 2 instances should be always running. 4 will be the maximum capacity as part of this automatic scaling group, and desired capacity that we can start with the 3. Okay, so this is as part of this auto scaling group. It will ensure once the resource is created. Now we need to set up the application load balancer. So suppose here as per the ASG, we can have any resources between 2, that is minimum 2 to maximum 4, which desired as 3 capacity. So we need an application load balancer. It should balance the traffic across the resources. Okay, so this line 98 to onward, it will start creating application load balancer. We will create it using this one, and here we are going to create, you can see the load balancer type as application. Okay, internal it has given false. So if you are not aware about the load balancer, again please watch my videos, previous videos. Again I will share the links in the description. There are types of load balancer. So there could be internal load balancer or internet facing. Okay, so you can see internal or external as well. So the load balancer which will be exposed to internet will be called as internet facing, and the ones will be internal or private, it would be called as internal one. Okay. So this would be our load balancer. It will use the security group. Again, we will be using for the EC2 instance, and we will use the two subnets, existing subnets. Now, as since this is application load balancer, we need the target groups. So target groups here we can say we have given this name as web TG, port 80 and protocol HTTP. Okay, and given this VPC ID. After the target group is there, we will set up the listeners. So the listeners is again important. We will specify some listeners rule. Here load balancer ARN, we will be given port, it will be 80 and protocol will be HTTP. And default action you can type, you can say it will be type equal to forward. So this will be the default action. We if you are aware that load balancer is a smart load balancer, so it has got many features. Load balancer, we can get some path based routing or sticky sessions, etc. So lots of things we can do. Here we will simply do that whenever it will be, so it will forward the traffic. So that the simple or default action we will set up as part of this. Finally, we are intending to get the output. So here we can see output ALB DNS name. So it should give the output of this application load balancer DNS name once the command is executed. Okay, so this is about this code. Let me now start launching or the deploying this resources. As you can see, I'm this inside this code. The first thing I would do is Terraform validate. So basically when we run Terraform validate, it will validate or review the code, whether the code has any issues, some syntax errors or something like it is, for example, some parameters are not defined, etc. So it will let us know. So after this we can run Terraform plan or init. If you want, we can run the init as well. Let's run Terraform init. And ensure you are given the access key ID and secret access keys. Okay, otherwise it will give the no credentials error. Now I have run the init again, but see, it's not needed to run the init every time. You can run whenever you can start working on project, but it's not needed to run it every time. After init, let me run Terraform plan, and let's see the resources that will be created as part of the script. So here you can see the plan will give all those things, and as we have covered in the previous video, it will give the plus button. So plus green, it will be for addition. There will be a orange color minus button. It will be when we see the resources will be deleted or destroyed. And there will be one another symbol when we need to change something. For example, suppose if you have defined this code already. Okay, and instead of this AMI ID, you have just changed this AMI ID to some different AMI ID. In that case, it will show as this, it will be changed, it won't destroy anything. Okay, I hope this is making sense to you guys. See here, it will create all those things as part of the script. Okay, now let's run Terraform. We have run Terraform plan. Let's run Terraform apply. We need to enter yes as the only approved values, and it has started creating the resources. It will identify dependency if any. Okay, and based on that it will create the resources, and I believe it could take hardly few seconds to create the resources. So once this is done, we will go to the console, AWS management console, and validate the resources that it has been created. Yeah, you can see the still the resources are getting created. Now it is creating automatic scaling group. Yeah, ASG creation complete. Normally at load balancing creation takes some time. So in the meantime, let's see what are the resources it has created. So let me go to instances. You can see as we have given desired values 3, it has started with the 3 instances. Okay, as part of the auto scaling group. Okay, let me just select any of this instance, and you can see it has given the message welcome to the web server. So this is our part of our bootstrap script or user data script. Okay, now about load balancer, you can see we have this load balancer. Okay, about other resources, let's go back to the code. Yeah, here you can see code has finally completed, and it has given the ALB DNS name as this is the DNS name of our application load balancer. You can see here. Okay, as we have added the final line that we should get this output. Now let's go back to the automatic load balancer, and you can see this is the DNS name. It is matching to what the output that we have received. Yeah. So you can see our load balancer has finally created. Now about other resources, let's validate which are the other resources that it has created. For automatic scaling group or ASG, see, it has given this name that since we have created via Terraform, and as per our configuration, desired capacity is 3, minimum 2, and maximum as 4. Okay, so it should start minimum at least, even we there's some issues, there should be at least minimum 2 resources and maximum 4 resources. Let's go and check if we can. Let's what's happen when we delete one of this resource. Let's see. Let me delete this one. So our intention is to get to see if we select this one, and let me just terminate this one. Let's see how it happens. So we need to validate whether our ASG, that is automatic scaling group, is working or not. Okay, I will also delete, let's see, another one, because we have set minimum there should be 2 resources. Okay, now let's see. So now let me go to auto scaling group, this one, instance management. Now let's go back to EC2. You can see this instance is getting initialized now, the first, this one. Okay, so it has started initializing the new resources because it identified the difference of the desired or minimum capacity and actual capacity. So this is working. Okay, let's validate about automatic load balancer, so the application load balancer. Let me go to the ALB. Load balancers here and target groups. Here this target group has been created today. Okay, this is what we created as part of Terraform. You can see on the details here. Yes. And if we suppose, if we here you can see load balancing algorithm, it is round robin. So round robin means it will be no, if it's passing traffic to instance 1, in the second go to instance 2 and 3, like that. Okay, suppose if we do any changes here, Terraform will validate that there are some changes that has done, because the way Terraform work is, it is it's declarative language. So whatever we have mentioning in the code, it will create those resources, and if there is some mismatch as per the configuration, that is the actual value and the values as per the code, there will be some changes. So Terraform will identify and it will change, because at the end of day, it should be what is there in the Terraform code should be those the resources should be executed or deployed. Okay, so even we will do some manual changes in the next run. When we'll run again the Terraform apply command, it will just roll back the changes that we have done manually. Okay, so I hope guys this point is clear. So friends, that's it for today. And now I would request you also, once you have done with this exercise, please don't forget, here you can see it has started the third as well, because we have set the desired value as 3. You can see there are 2 resources are getting initialized, so there will be always 3 resources that should be running. Okay, now what I would do is I will just run terraform destroy command because I don't want these resources to be running further. Let me just run destroy. Here again we need to run yes as approval value so that the resources would be destroyed, and let's go ahead and see. So soon we will observe the resources getting terminated. So it is destroying the resources, automatic scaling group, all the things it will destroy in one go because we just run plain vanilla that Terraform destroy. If we wanted to retain some of the resources, we can either hash out those from the code, or we can provide some syntax changes so that those resources will be. So there is one syntax that we can add when we run Terraform destroy. It will just destroy those resources only. So based on our configuration or based on command, those resources will be deleted. Now it's not yet started destroying, but let's see. It's still destroying. Yeah, let's validate once the resources are destroyed. Yeah, resources are still getting destroyed. Let's wait for a couple of few more seconds until we get the message that all resources are destroyed. Okay. It's almost done. So we can validate the resources. Instances, it is. Yeah, similar to what automatic application load balancer takes time. So even destroying also takes some time. Okay, so as you can see, and if there is some interdependency, again that also contributes to getting delayed when you destroy the resources. Yeah, it's still destroying the resources, but yeah, since we have given destruction of all the resources in settings, taking it is taking some time, but that is not an issue. It will destroy all the resources and we don't need to do anything manual. Okay, so please ensure once you are done, please ensure you destroy all the resources, so that you should not you won't get any billing associated with this table. So friends, that's it for today. I hope you really enjoyed today's video, and I will share the associated the links with you, the important URLs with you, which we referred during this video. Thank you so much for your time, friends. Please don't forget to like, share, comment, and subscribe to my YouTube channel. This is Cloud with Mohsin, and thanks again for your time watching this video. Thank you so much, and have a great day ahead. Thank you. Bye bye.